everyone. My name is Rebecca Bickham, editor of NACE International's Materials Performance magazine. Joining me today on the podcast are NACE members Joe Mazzella and Tom Hayden with Engineering Director Incorporated. They are joining me today to discuss the work they are doing to combat corrosion through the use of machine learning. Hi, Joe. Hi, Tom. How are you both doing?
Fine. How are you doing, Rebecca?
I'm doing great. Thank you.
Hey, thanks. I'm doing great too. Thanks.
Good. Thanks for being here. So this project of yours is one that we featured in our August 2020 issue of MP, and I wanted to have you both on the podcast today to give our listeners more insight and detail than what was included in the article alone. Joe, let's start with you. You are the CEO of Engineering Director Incorporated, also referred to as EDI.
Mm-hmm.
So would you please tell us a little bit about the company and your background?
Sure. So I've had a couple of career paths along the way. The first and foremost, as it relates to today's subject matter, is working for major high-performance coating manufacturers, with my primary role of managing architectural and engineering teams to get specified. And the other significant role was working as a magazine publisher in the construction industry for McGraw-Hill Construction. I was publisher of the Chicago Architect magazine for the American Institute of Architecture, and also regional E&R magazine for Midwest Construction.
Wonderful.
And then,
anything else, Joe?
No, not in terms of my background. Would you like to know a little bit about Engineering Director?
Sure.
Okay. So, as we said, currently I'm the CEO of a consulting firm called Engineering Director, or EDI. And we're focused on spatial analytics and artificial intelligence, primarily associated with earth, atmospheric, and environmental sciences, and their related impact on underground and atmospheric corrosion. So that's what we're focused on right now. And Tom and I like to refer to Engineering Director as a boutique consulting firm specializing in developing, implementing, measuring lean business process and strategy. Through use of information technology and, as it's spelled out in the article, geographical information systems. And at the core, we're primarily data scientists that provide what we call real-world applications, what we refer to as full data science spectrum. So we develop advanced machine learning algorithms, we build data science web applications, and then we distribute the data science throughout the organizations.
Great. Thanks, Joe. And Tom, you're the CFO of EDI and you're a lecturer at Northwestern University. Could you tell us about your background and how you became involved in the corrosion industry?
Definitely. So my background is actually in consumer tech. So I don't come necessarily from the corrosion business. I was a computer science graduate student, and I left that and I worked for Facebook in their risk and payments division. This was back when people used to play Farmville. I don't know if any of your listeners are Farmville players, but if they played Farmville back in 2011, I was keeping your Farmville cows from being stolen.
Fantastic.
I totally come from the consumer tech business, which has adopted machine learning and a lot of these advanced technologies probably for about a decade now, if not more. And from Facebook, I moved to a company called Grubhub, which, if you're in the U.S., is sort of the dominant player in online food delivery. And that's actually what led me to meet Joe. Is when I worked at Grubhub, we use a lot of weather and atmospheric data in our business. So you can imagine if you order carryout a lot, like you're going to order carryout when it's rainy outside, or everyone orders carryout when it's snowy outside. So the business was actually very correlated to the weather. So we would use a lot of weather data to try to predict how many orders we're going to get so that we could staff customer service and sort of staff how our business operates and drivers and stuff like that. So I run an open source library for processing real-time data from NOAA, real-time sort of government weather data. And that's what led me to meet Joe, because Joe was looking for sort of real-time and historical weather data for a lot of the work that he was doing in corrosion. And so that's sort of how I entered the corrosion space, kind of coming sort of tangentially from consumer tech through to weather through to corrosion. But it's actually been really fascinating, and I really love working on these problems in particular because it's sort of a really different twist of you can use weather data to predict corrosion, to predict all sorts of different types of aspects of the industry, and it's been really a fascinating endeavor.
Okay, so Joe, you'll probably want to take this next one. Could you give our listeners a brief overview of the project that involved estimating corrosion growth rates in underground pipelines?
Sure. So the business case for the paper involves how to cost effectively and efficiently assess environmental conditions, and then the related impact of corrosion on underground pipeline using geographical information systems and spatial data that we spoke about, but with limited excavation. I think that's the key to this. So we are more proactive than reactive in predicting the likelihood of corrosion at locations over a broad geography. And in the case of this project, the broad geography was over North America. And then the business case for the project, the objective was to proactively target those areas that have the highest likelihood of advanced corrosion based on the rate and degree of corrosion, and because of that, reduce risk of failure while we were trying to maximize both the capacity and related cost of inspection. So in more technical terms, we use geostatistical tool analysis tools I guess the best word is to emulate what is occurring in the landscape that is of interest or that may impact corrosion, such as pH and electrical conductivity in the soil, power lines nearby that contribute to alternating current, AC interference, perhaps with rectifiers, magnetic anomalies, both paleomagnetic in the ground and maybe atmospheric, road salts, and other known contributors to corrosion of the underground pipeline. And then from there, use this data to generate inputs into machine learning, which is Tom Hayden's area of expertise.
All right, so let's move on to you, Tom. Would you discuss the machine learning aspect of the project?
Yeah, absolutely. So if you take a step back and sort of think about why companies or why anyone chooses to use machine learning, and one of the reasons is for risk mitigation and for optimization, right? So if there's ways that you can run your business better or highlight things that you might miss normally or identify risks that you normally wouldn't find, like machine learning is tremendously valued. For instance, we used it at Facebook. We use machine learning all the time to try to, I mentioned the Farmville cows, but we had all sorts of machine learning models to try to make sure that there weren't fraudulent transactions going on and to identify high risk actors in the network and so on. So this isn't actually all that different. So what we chose to do is we essentially took, from a North American pipeline operator, we had ILI observations on about 2.2 million girth weld addresses. And so we wanted to ask the question, given those ILI observations and the growth that they have actually observed on those ILI observations, can we build a model to try to predict it? So if there's a future, so that we can predict, can we find errors? Can we optimize their process? Can we optimize them doing digs? Like, how can we optimize sort of their process for identifying risk and for running their business? And so we built this we built this model. As Joe mentioned, we brought in all sorts of exogenous variables. So we brought in things like paleomagnetic data. AC interference is a big topic in corrosion right now. So we brought in some AC variables related to AC interference because we have data on the proximity to power lines. And we brought in data from atmospheric data, and we brought in soil data, and we brought in as much data as we could. And we essentially we built a model. And the way machine learning works nowadays is you essentially give all these variables to the computer and you say, figure out which variables matter and construct this model for me. So we put it all in, it built a model, and then we were able to identify for any girth weld address or any new girth weld address or any new point along the pipeline, the potential risk factors. So we could say, what is the probability that this corrosion growth rate is going to be above X? Or we can also ask we can also ask the model, like, what do you think this specific growth rate is at this specific location? So it allows us to sort of take a really interesting macro view where we can zoom out, see sort of the overall level of corrosion and the overall estimates, and then we can start to zoom in and identify points of risk.
So in addition to all that, EDI is also creating a computer vision app, which can detect corrosion and kind of tell about, the level of corrosion. Who wants to speak to that?
Oh, I would love to talk about
that.
So, yeah, so this is a project I have really enjoyed. So with a background in machine learning, computer vision is sort of a part of machine learning, right? So computer vision is using images to identify things. So you may not know this, but you probably interact with computer vision algorithms all the time. So anytime you interact with facial recognition, so if you're unlocking your phone with your face, there's some computer vision going on there. Or anytime if you use Snapchat or TikTok or any of these fun apps that do computer vision stuff, whether they transform your face or make you look old or make you look young, there's all these cool apps, they all use computer vision. So I wanted to bring some of this technology that is really popular in the consumer space over to corrosion. And so what we did is we built an algorithm where we fed in about 10,000 pictures of of corrosion. I basically walked, the Chicagoland area is not short of corroded things. So I walked around the Chicagoland area and I took about 10,000 pictures of corrosion. So things on elevated train tracks, things on buildings, on architectural elements, just sort of all over the place. And we built this algorithm, and it's a computer vision app. So what it does is it takes a photo, and using all this data I plugged into it, can identify if corrosion is in the picture. And we were able to do that successfully. We have an app in the App Store called Optical Surface Recognition, where you can go download it yourself and try it now, and point it at a surface, and it will tell you if that surface is corroded or not. And it will give you a confidence score to evaluate how confident it thinks it might be corroded. So, for instance, if you were to point it at it looks like a wooden floor, for instance, you would probably get a confidence score of very close to 0. But you could point it at something that might have a little bit of corrosion variable, corrosion visible, like there might be some bubbling in the coating or something, and you might see that confidence score go up a little bit. So eventually what we want to do is, this is sort of our proof of concept. Like, let's build this app. It's pretty cool. It can detect corrosion. It can detect some confidence scores, and let's start layering more technology and more stuff on there. So the ultimate goal is we want to get to a point where we can say, well, let's detect levels of corrosion. So not just like, is it corroded or not, but let's also detect how corroded is the surface. Is it 1% corroded? Is it 5%? Is it 50% corroded? And then you can start, once you have that, you can start to do really cool stuff and say, like, what type of corrosion is it? Is it flaking? Is it chipping? Is the coating damaged? How serious is the pitting? You can start to do like really interesting computer vision apps with nothing more than sort of consumer grade cameras. And that allows you to have some like really cool ideas you can think about. So you can imagine putting it on like piers as boats go by. You can sort of scan the boat for corrosion on the exterior. You can start to do some really cool applications that are passive in nature but might have a big impact. Yeah, so again, it's called Optical Surface Recognition. I invite your listeners to go download it in the App Store. I think if you just search the App Store, the Apple App Store, Optical Surface Recognition, it will pop up, and you can download and play around with it. And it works on videos, and it works on like real-time videos, and it works on images. So yeah, definitely check it out.
Thanks, Tom. So you're also heading up a NACE task group, TG589. Could you tell us about that as well?
Yeah, definitely. So I think this is actually very important. So other industries, like for instance, radiology, what they have done is they've built these really interesting data sets of, like for instance, in radiology, of mammograms. So they went out and they've collected, tens of thousands or hundreds of thousands of different pictures of mammograms, and they've then gone through and labeled all of them. Like, is a tumor visible in this image? Is a tumor not visible in this image? Where is the tumor in this image? And so what that has done is that's created actually a revolution in machine learning technology as it applies to radiology. So a bunch of computer scientists have all of a sudden found these data sets and started building really interesting computer vision applications. And it's really, for that industry, really moved the industry forward quite a bit. So like, I personally have a vision, and I think like the industry would really benefit from having a working group like this, like what they've done in radiology, to collect images. So one of the things you need for computer vision is a great diversity of images. So, images of corrosion on the Chicago L train only gets me so far. We need images of like marine-based corrosion. We need images of pipeline-based corrosion. We need like above ground, below ground corrosion. We need corrosion on different types of architectural elements that may not be in my training set. So that's what you really need, is you need to build this like really large and diverse set of data. And so that's what I think the value of the working group is we can interact with people in other industries that are not, Joe and I work primarily in sort of the pipeline business and in the pipeline corrosion space, but there's all sorts of interesting aspects in coatings and marine corrosion. And so what we wanted, so that's part of the vision, is to get all these different groups together and collect this data set, and with the idea that it'll bring in computer science researchers and people that do algorithms and people that do computer science to start building like really interesting technologies that might move the industry forward in terms of automation.
Okay, wonderful. So this last question is for both of you. What plans do you have for the future? What are you going to be working on in the future? And is there anything either of you would like to add before we conclude today's podcast?
Yeah, definitely. So I'll take this first, and I'll let Joe chime in. So we have a paper in the NACE 2021 proceedings, which is an advancement of what we did in the 2019 and in this year, which is building more advanced machine learning algorithms. So we've started to identify new variables to bring in, especially new variables from the plant, what we call the plant soil atmosphere, which are things related to soil and soil conditions and soil wetness and conductivity and resistivity. So we have a model going there. And we're also working on, especially in the optical surface recognition, building more advanced algorithms. And as I mentioned, building in some of these additional components into the algorithm, just flaking and things like that. Did you want to add to that?
I think you did a good job. We're also working on launching a couple of tools, key tools, geographical information or GIS tools. We're launching a GIS platform and related tools.
Yeah, at the end of the day, for all of this to work, we need really good GIS systems. Almost everything in the corrosion space has some geographical element to it. You know, whether it's because it's in a certain climate or whether it's because it's underground in a certain location. So, like, before we can do any of the really cool machine learning stuff, we have to do a lot of GIS stuff, which involves, you know, identifying things where they are, like where they are in relation to certain other elements, weather conditions, bodies of water, floodplains, things like that. They all contribute into this. So, like, building out a very strong core GIS processing system is sort of our biggest priority right now. And I think we're making a lot of progress on it. And if you visit our website, engineeringdirector.com, you can read more on it. We've got a lot of really cool stuff on there. And yeah, so that's definitely the direction we're going in.
Well, thank you so much, Joe and Tom, for joining me today. This is where we'll end things. Again, my name is Rebecca Bickham. I'm the editor of Materials Performance Magazine, and thanks so much for listening.